Hello, welcome to the Mysterious Productions Laboratory. I'm Pedro. And I'm Chris. Today we are going to explain Newton's laws of motion. First, let's explain the first law of motion. The first law, as it says on the giant sticky note, if an object is stationary, it will not move until acted upon by an outside force. And if an object is moving, it will stay moving unless acted upon by an outside force. Hey, can you give an example? Just watch. Cool. Because of inertia, or the tendency of an object to resist a change in motion, I should slide over the top of the car when it stops. Oof. You okay, Pedro? Yeah, but I'm gonna lay here for a little bit. Guess what? We can explain why you stopped. Because of inertia, your body resisted to change direction and you flew off the car. The outside force that stopped you was that rock when your head collided with it. Nice. Yeah, it's very cool. Now for the second law of motion. I think we're going to do some math on this one. Yeah, and lucky for you, I made a very small slideshow when you were on the ground. Cool, let's watch it. Okay, to represent the second law for us, I made a small PowerPoint. Newton's second law states acceleration depends on mass and on the net force acting on the object. The equation for this would be acceleration equals net force over mass. An example would be net force equaling 10 newtons and mass equaling 5 kilograms. Acceleration would equal 10 newtons over 5 kilograms. Acceleration would equal 2 meters per second squared. So, how'd you like it? It was good, but there wasn't a cool example. What would be one? Look here. If Chuck Norris threw a punch with a force of 550 newtons and a mass of 2 kilograms, what is the acceleration of the punch? Come on, I've already been to math class. Do it! Done. Cool. The net force equaled 550 newtons and mass was 2 kilograms. So the acceleration would be 550 newtons over 2 kilograms. Acceleration would equal 275 meters per second squared. Hey, wake up! Are you guys still watching? Yeah. I think we're doing Newton's third law now. Oh yes, the third and last law of motion. Should I explain this one? Nope. Are you gonna do another slideshow? No, this time I'm gonna show a small movie. To the computer! Here we go. First, let's explain the third law. If one object exerts a force on another object, then the second object exerts a force of equal strength on the first object. Basically, for every reaction, there is an equal and opposite reaction. For example, when jumping, you push on the ground with your feet. This is an action force. The ground pushes back with an equal and opposite force. This is the reaction force. This concludes our project on the 3 laws of motion. Yeah, have fun watching credits.